Sorry for the delay. We had some technical issues. So today we're having Ritesh.
Yes.
Today we're having Ritesh to discuss, tell us all about Bitcoin. So take it away, Ritesh. Thank you very much.
Thank you. Thank you, everyone. So before I begin, just introducing myself. I am a software developer plus technical program manager. I work in the high-frequency trading area for the past few years. Bitcoin isn't my primary field of work, but it is, as an enthusiast, I like to read about what's happening in Bitcoin, the design, the philosophy behind it. And it's also an intersection with another passion I have is macroeconomics. So Bitcoin is actually at the intersection of tech and economics, right? It's a digital currency. It's a phenomenon that's been successful where others have failed repeatedly. A lot of big corporations, a lot of smart people have attempted this and failed, and this is one of the first successes in this area. So in this talk, I won't be sharing code with you. I won't be talking a lot about technology. I will talk about network concepts behind Bitcoin, how the protocol behaves, how different parties interact. But I'll start off with what exactly is money, right? So background of what exactly has been our history with money. So hundreds of years ago, we all had the barter system. So you produce something, I produce something, and if we felt that I wanted your item and you wanted my item, we would exchange. And every time we exchanged, we might have a different quantity exchange between the two of us. And there was no certainty in when I would want your item or when there would be demand for what I'm producing. So for example, let's say I produce bread, and this gentleman here is a dentist, right? So he's hungry, he's looking to buy bread, and I have a toothache. So I go to him and I say, okay, I'll give you a loaf of bread, you fix my toothache. And he says, yes, I'm hungry, so I'll take that and I'll fix your toothache. And he does that, right? He's done with the bread, he's happy, but my toothache's still there. So I go back to him and I say, hey, I need another fix. There's some more bread. And he says, sorry, I don't need bread. Well, we can't do an exchange anymore, right? So there are two producers with two different items, but there's really no demand over here. So that's where the barter system kept on failing. If there was no coincidence of wants, there was never really an exchange happening. Slowly, people evolved into a system where they use something else instead of barter to exchange goods. And it just turned out that it became gold. In some countries, it was silver. In some countries, it was bronze. In a lot of countries, it was a mixture of different precious metals. Gold was somehow the most sought after. So as civilizations evolved, mankind sort of developed greed to accumulate gold. And that led to this phenomena where people would get together in a marketplace. I would bring bread, someone else would have a piece of gold, and we would say, okay, for that much gold, I can give you 3 loaves of bread. For a certain other amount of gold, I can give you 5 loaves of bread, and so on. So gold became the medium of exchange between people. In some countries, silver, in some countries, bronze, in some countries, certain other...
Seychelles.
Maybe. I've never heard of that. But
definitely, it still exists.
Oh, okay. So this greed, this scarcity of a specific material led to people wanting to exchange or produce or work hard to get more of it accumulated, right? That's what we all do today as well. We like to work hard, accumulate wealth, and then with that wealth, we'd like to spend it. So that's what gold really started off. And then slowly it converted into a cash-based system. So we started having currencies. The currencies were issued initially by certain organizations that came to be known as banks. A country could have 1, 2, 3, or 4 banks offering their own currencies. And it just sort of hit off the idea. People said, well, currencies are much easier to manage, right? I can put it in my pocket. Gold, it's difficult to hide. Currencies, I can stack them up, put them in a vault. Gold is, it doesn't have to be always bars of gold. It could be stones, shapes, irregular shapes. Currencies had this malleability to them. You could fold them, put them in your pocket, take them, carry them easily with you, hide them. The problem of gold being stolen was there with cash as well. But there was something special about cash. There's something special about currency. There's someone backing it. So when these banks came up, they said, here's $1, and this $1 is equal to, let's say, 1 gram of gold, right? So you were always sure that if I ever took this dollar back to the bank and said, can I have my gold back? They would give you 1 gram of gold. So that gave you confidence. Now, as countries evolved, governments had to centralize this system. So they said we cannot have multiple currencies, and the currency will be issued by a central bank, a federal bank of this country. And that bank will be, they were initially controlled by the government. Some of those central banks are still controlled by government. Some of those central banks are independent now. So these banks today say, well, not today, but at that point said, it's the same currency. Here's an exchange rate. For my $1, I will give you 1 gram of gold. And people were happy with that. They slowly adjusted their behavior. They migrated themselves to that currency. And that led to progress. We had different industrial revolutions. Different industries came up. A lot of countries made progress. There were obviously some wars in between. But currency as a medium of exchange firmly established itself, right? Now, at this point, every country in the world either backed their currency with gold or they backed their currency with another currency. So obviously, the United States has been one of the most powerful countries in the world. So when their central bank said, our $1 is backed by a certain amount of gold, everyone believed them. There was no reason to not believe them. But there was never an opportunity for anyone, or the opportunity to go to the bank and say, here's $1 and give me my gold somehow went away over a period of time. And no one really realized this, right? And then sometime in the 70s, the US said, hey, starting today, my currency is not backed by gold. It's just backed by me. I'm a powerful state. You need to trust me that my currency will always be valid because as a country, I'm not going to go away anytime soon. I'm going to survive for the next hundreds of thousands of years. And people believe that as well. So we moved on. So we moved on from gold-backed currencies to currencies that were just backed by the confidence of different countries, the leaders of those countries, and so on, right? So coming to today's world, we have different currencies all over the world. None of them are backed by gold, but they do have confidence in them. If let's say we give this gentleman $1 billion and said, hey, you can keep this $1 billion in Australian dollars, or you can convert it to any other currency and spend it for the rest of your life, it's very likely that he's going to spread that exposure out. He's like, why would I want to keep all my currency in Australian dollars? Let me buy a few US dollars, a few British pounds, a few euros. But he's very unlikely to go and buy currency from some South American country, right? No offense, but certain countries have less confidence and certain countries have more confidence in you, right? So you are likely to believe in currencies which are backed by stronger countries versus countries that are economically weaker or don't have a stable history. So that's where we are today. That's our cash-based system. We have an exchange rate that's market-driven. The exchange rate is market-driven for most of the countries. Most of the democratically free countries have an exchange rate where it's all supply and demand based. If all Australians start buying US dollars, the US dollar goes up. If you stop buying US dollar, the exchange rate goes down, right? So moving forward. So what cash-based systems have is, in the market, there's always a direct interaction between the buyer and the seller. If I need to buy something from you in cash, I have to meet you, I have to hand you the cash and take whatever item I'm purchasing from you. But we don't have to reveal our details to each other. I don't have to tell you my name. You don't have to tell me your name. Right? We could remain anonymous. You can't trace me once you've taken my cash. I can't trace you once I've taken your item and we've walked away. There's no electronics involved in this. Right? It's just physical, take a bill out of my pocket, hand it to you, and I get something from you in return. So there's a standard user-to-user mode. There's a user-to-merchant mode. There's not much to it, right? It's just basics here. And if someone steals my money, I've sort of lost it forever, unless I can trace that person back and prove that he stole it from me. But otherwise, in all other cases, it's lost forever. Then we came up with credit card-based systems. Now, a lot of people confuse credit cards in this concept of Bitcoin. So it's better if I explain this and sort of show you that it's somehow separated from currency. A credit card allows you to do what a cash bill lets you do, right? You go to the buyer or the seller, you swipe your card, you pick up what you need. But when you swipe your card, you reveal your details, potentially. There's an electronic component involved. If the electronic component isn't working, you can't make a deal, right? You can't swipe your card, he can't accept you, he can't give you the items. If the online system goes offline for whatever reason, we're down, we can't work. Credit cards are never, or it's possible to do a user-to-user mode, but it's more prevalent with user-to-merchant mode. There's some level of security. If someone steals my credit card, I can get it blocked. The transactions can be reverted. Anyone that's stolen it and used to purchase goods can get in trouble, and so on, right? But credit cards are backed by cash. I get a credit card that has a limit based on my income, right? In certain countries, your credit card is backed by how much you have in your savings account. So there's always a cash component involved that lets you decide, or lets the vendor decide what's your limit for your credit card. So credit card and currency, you can club them together. They're not really separate things. Now let's talk about digital currency. And how is it different from digital cash? Credit card is essentially your digital cash, right? So when you can put your cash in your bank account and swipe your card, you've converted your physical cash to digital cash. A digital currency, on the other hand, has nothing that it's backed with, nothing in the physical world that it's backed with. There's nothing physical about Bitcoin, right? If I have a few Bitcoins, they're not backed by anything in the world. We'll come to that. When you convert digital cash to physical cash to digital cash, it's a 1-to-1 ratio. But Bitcoin does not have a physical equivalent, so there is no concept of 1-to-1 ratio or any other ratio. Digital cash is as good as spending physical cash, right? If I earn $1,000 a month, I can convert half of that to digital cash, or I could not. If I spend, I spend. If I don't, I don't, right? It's my savings. It's whether it's digital or physical, it's the same thing. Digital currency, on the other hand, can be converted to another currency. Could be a physical currency, could be another digital currency. And there'll be a conversion ratio, which is the exchange rate. And that exchange rate is market determined, right? As I go along, if you guys have any questions that you feel prevent you from following what I'm saying, just raise your hand. All right, so now let's look at two important concepts about digital currency. And I'll just use the word Bitcoin instead of digital currency, because that's what we're talking about here. So there's minting, and then there's the ledger. So minting is creating currency, printing currency, and ledger is maintaining a history of who has how much, right? So that's how a typical blockchain or the ledger of a Bitcoin looks like. It has blocks which have a header which point to a previous block, and that's why it's a chain. It's a chain of blocks, essentially. Each block has transactions in them, and these transactions are sort of arranged in a data structure that make it easy for anyone to go through a history of transactions relatively very quickly. So now, when you go to the mint, if you've seen the Australian Mint in Canberra, there's certain machinery that's been set up to print currency, print coins, and so on, right? Now, this infrastructure was set up by the government. It cost them a certain fixed amount of money to set it up, to print the first dollar bill that came out. But then subsequent dollar bills came out at only a marginal cost, maybe just the electricity that was spent in, the initial infrastructure was set up. So that's what minting is about. There's an initial fixed cost followed by a marginal cost to run that infrastructure. Now, how much currency you print keeps a check on how much currency is in the circulation, and that keeps a check on the inflation and the price increase and so on. So if the government starts printing a lot of cash, starts distributing it, every one of us would start going buy properties, property prices would go up. If the government sucks the money out by raising taxes or some other means of sucking the money out of the system, we have less money in hand, we have less money to spend, property prices go down. And that's applicable to any other consumer item, right? When I say consumer item, that means hopefully none of us can easily go and buy weapons or nuclear bombs. So the prices of those items is not what you would say is a consumer item, right? So those are not consumer items. Digital currency has its own minting process. A lot of you know that Bitcoins require that a puzzle be solved for someone to earn a Bitcoin. We'll go into what exactly is that. The puzzle requires a certain amount of effort, certain amount of time to be spent in solving that puzzle. And it's not very easy to keep solving that puzzle once you've solved it, right? So the difficulty level keeps on increasing. That keeps the amount of Bitcoin being generated within a certain limit. We don't want an infinite amount of any currency it shouldn't be possible to keep generating infinite amount of any currency. Physical currencies are controlled by government. Bitcoin has a system that requires you to solve a puzzle, which makes regular creation of Bitcoin difficult. Now, what's a ledger or the blockchain? So an interesting thing about Bitcoin is it's a decentralized system, right? So a ledger is actually a decentralized repository of all the transactions that have ever happened in Bitcoin, starting from the very first transaction that an unknown person called Satoshi did, all the way till today. You can look at all of those transactions. There's probably hundreds of millions of them, right? So you can have a look at starting from transaction number 1 to whatever we are today. And the system is decentralized. It's not maintained by any one central node, any one central server or computer. It's spread out. Everyone has a copy of it. Everyone maintains a copy of it, and everyone regularly updates their copy of it. But there's a protocol across all these maintainers, all these nodes that maintain the blockchain with them on how to extend the blockchain. How do we add blocks to that? So we'll look at that as well. Now, a transaction in the Bitcoin world essentially has a timestamp when the transaction happened. And this transaction is signed by one of the person, which is obviously the person who's giving away the money or giving away the Bitcoins, right? So those are two very important components of any transaction to make it a valid and a legal transaction. I'll move on to some slightly difficult mathematics. So there's a concept of a hash function. It's a function which has 3 properties. It can accept an input of any size. Its output is of a fixed size, and it can be easily executed, right? So that's all what a hash function is. Certain hash functions can only take a fixed size input, but they can be easily converted into a hash function that can take a variable size input by a simple transform called the Merkle-Damgard transform. Not really relevant, but just for your information. Bitcoin uses a cryptographic hash function. Now, this hash function has 3 additional properties: collision resistance, hiding, and puzzle friendly. So collision resistance says for two inputs, when you give them to the same hash function, the output should not be the same. Or for two different inputs, the hash of them should not be different. Right? So if x and y are not equal, then the hash of x and hash of y should not be equal either, right? So that's what you say is collision. Hiding, it says if I know the output of a hash function, I should not be able to reverse engineer the input of the hash function. And puzzle friendly is I'll let you read that one. It's not really important if you don't understand what that sentence says over there. All it's saying is if there's an input which is appended with, so this right over here.
Would that be similar to what the least amount of moves to be able to achieve the collision or the hiding? Is that what you're saying?
Sorry?
The puzzle friendly, would that be like an example of sort of like the least amount of moves in a sense to achieve the top two? Is that what you're saying? Like for example, to achieve the top two, if it might take 1 million sort of steps to achieve collision resistance and hiding, right? But if someone managed to do it in 800,000 moves or transactions, is that being puzzle friendly?
Not exactly. Not exactly. Okay. So let me explain something else as well. So Bitcoin says that these are my rules, or these are what a cryptographic hash function should follow. You know what? Even if a hash function doesn't really follow this, it can still be used for Bitcoin. As long as it's humanly impossible for someone to come up with a machine that can break any of these rules. So if there's a hash function out there that does have collisions, and none of you can detect that, then that's fine. We can use that hash function. Right? That's all we're saying here. It should be infeasible, not impossible. Yes?
Just on the last one, what does the actual K represent? Is that a hash of constant appended to X equals Y?
No, that's just K is an input and X is another input. So K is chosen from a different distribution, and X is an input that you entered.
Okay.
And when the two of them are appended,
Okay. All right.
and a hash of that's taken, the output is certain bits long,
Yes.
right?
It'll never be the same as well. Never repeat.
Yes.
Yeah.
Yeah. Yeah. So, sorry, so just the two main concepts here are really collision resistance and hiding, right? That's what should be infeasible, but not impossible. That's all you need to understand, right? So if there's a hash function out there, and there have been, for example, MD5, that have been reverse engineered, collisions have been found, and now there's a mathematical proof out there that says, here's how you break MD5, and that's fine. We'll just stop using that. We'll find another hash function that's better, for which no one has yet reverse engineered or found a fault in yet, right? Now the Bitcoin network has computers, very powerful ones, or they could be your home PC as well, which are called nodes. Now these nodes run a special software that's released by the Bitcoin developer community. It's called the Bitcoin core software. Once you run that, your computer joins the peer-to-peer network of Bitcoin nodes and becomes a node itself. It can then track transactions, maintain a copy of blockchain itself, and share that with any new node that comes in, right? So anytime a transaction is published, the nodes or the initial node on which the transaction is registered needs to publish that to all the other nodes. And all the other nodes need to continuously listen for transactions. They group them together into one block, and that block is then appended to the blockchain. Now this is a very simplified working of Bitcoin. We'll go into detail of how a transaction is done, how a block's generated, and how it's appended to the blockchain. Now, the nodes work in a decentralized manner. There's no governing authority. The only governing authority out there is the one that releases the software. But you're free to modify that software maliciously or honestly and get onto the network and try to disrupt it. Right? So that is a possibility. And we'll see how, I'll just explain that. I don't have slides on how that's infeasible or how that really hasn't happened yet. Yeah? Now, another concept on Bitcoin is identities. So identities on Bitcoin is similar to how we have that in the real world with cash-based system. So because I want to stay anonymous, when I hand you cash and take what I need from you, Bitcoin offers me the same flexibility, which other digital currencies in the past could not offer. Bitcoin says all you need is a public and a private key. Your public key is your public identity. Your private key is for you to keep safely, right? My private key is my wallet. My public key is my address. I tell everyone what my address is, but I don't share what's in my wallet, or I don't tell them where I keep my wallet. That's what a public and private key is. So public keys are generally long, so you could take a hash of that and give someone a hash of that, because the hash is usually smaller than the input. So the hash is just a small way to, or is the easy way to compress your public identity. You are known on the Bitcoin system with that identity. Now you could create 100 public-private key pairs. As long as you keep your private keys safely with you, you can use all 100 public keys as many times as you want, in whatever sequence you want. There's no one stopping you. There really aren't any rules. And the process of creating a public and private key is well documented on the Bitcoin software system. So again, it's a decentralized system. There's no central authority handing you what your public key is. You generate that on your own. Now, when there's a transaction, two people on the Bitcoin network get together, or maybe outside the Bitcoin network, we could meet in the real physical world and say, here's my public key. And you could say, here's my public key. And we'll say, okay, well, let's do this exchange. This is one Bitcoin. So the way it would work is you would sign the transaction with your signature. You would say that here is the payee, which is me, my signature. So let's say this gentleman here transfers money to me. He'd say, here's my public key. Here's his public key. Here's the amount of money that we're transferring to each other. And here's my signature. And that's it. And then that transaction gets published. But the transaction has to say, where is it getting the source of its money from? So for example, if this person over here transferred money to me, he needs to put in that transaction, where is he getting that money from? So he must have had a previous transaction in which he received money. So he needs to just point to that, right? And then we just broadcast this to all the nodes that we're connected with. And then the nodes will connect my transaction and some other transaction, and they'll group them together in a block. Then these nodes work on mining the next block. The mining involves solving a puzzle. So they need to collect transactions into a block, solve a puzzle, and then they can propose that block as the next block on the blockchain. And then they will publish their proposed block back on the nodes. Other nodes will listen for that, validate whether that's a valid block that's been published, and say, okay, if we agree with you, you solved the puzzle correctly, we all agree with you, and we will append this block to the blockchain, right? If I have a malicious node that tries to publish an invalid block, because I collected, let's say, just one transaction and said, okay, I'll quickly create a block and try to publish that out, other nodes won't accept it. That node's invalid, that transaction's invalid. Unless the block's accepted by all the other nodes, the transactions in that block are not valid. So this consensus among the nodes is a distributed consensus. There's no central authority saying this transaction is valid, this block's valid, this is the person or this is the node that's really solved the puzzle. So we're going to say that his block's the next block. The nodes all need to agree amongst themselves. Now that's a possibility that there's let's say someone with a lot of money says, I'm going to put in 100,000 nodes on the network, and I'll try to beat this system. my 100,000 nodes will agree on my malicious block and my malicious transaction, and will create the next block on the blockchain. They'll be the ones doing that. Well, that's mathematically, it's possible. No one's yet been able to do it. The reason being, the reverse mathematics says you need to own or command control over 50% of the nodes on the system to maliciously influence it. If you can't do it if you don't have that level of influence, you will not be able to maliciously influence them, right? So no one has so far been able to control 50% of the computing power on the network. It's not financially or mathematically impossible. It's just very difficult, and no one's attempted to pass through it. Now, why? Yeah.
So then you only need half of the nodes to agree for the transaction, or all of them?
So can I hear that, please?
So do you need all the nodes to agree on the transaction, or only half of them?
So if a majority of the nodes agree,
Majority. Okay.
yes. So if a majority of, so the question was, how many nodes do I need, and what exactly is the process of maliciously manipulating the system? Well, you need to have 50% of the nodes or 50% of the computing power behind the system to say that this is the next block. And once you can say that, you game the system. But no one's really been able to do this.
Which is it, 50% of the nodes or 50% of the computing power?
I use that interchangeably, whether it's 50% of the nodes or 50% of the computing power, right? Can I hold on to that question? When I come to solving the puzzle, this will become much more easier for you to understand it. Yeah. So I'll definitely try to answer that question in a few slides. So when you do propose the block, what's the benefit? Why would I want to have a node that would propose the block? Well, the benefit is I get the block reward, which is the only way for anyone to generate new Bitcoins. This is how Bitcoins are mined, right? And that's one of the core principles of Bitcoin protocols. The only way for anyone to generate fresh new Bitcoins is by being able to propose the next block, right? So initially, when the Bitcoin system was started and the software was published, the incentive was 50 Bitcoins for every block that you proposed and got selected. And then the protocol said, well, you know what? It's not going to be always 50 Bitcoins. Every 10,000 blocks, we will halve this. So it's a geometric progression, right? If you extrapolate this based on the number of transactions and blocks that we're creating today, it's estimated by the year 2140, the incentive would reduce to 0, and a total of 21 million Bitcoins would be issued. And that's the end of any new Bitcoins ever to be created. This is very interesting, right? So there is no limit on how many Australian dollars would ever be minted by the government. There's no limit on any currency. Yes?
Are blocks a physical space on a machine somewhere?
Physical, it's a data structure.
So is the person creating the block also paying for the physical space?
I'm sorry, can you repeat that question?
So is the person creating the block also creating the physical space that the block exists on?
So there's a file that basically has all the blocks that have been created and shared between all the nodes.
Right.
So if you're an owner of a node,
I'm sorry, I should be using
there's
nodes.
this massive file that has all the blockchains throughout all history, from the very beginning to the very end.
So you're paying for the machine and that's part of the creating the node.
Yes.
So let's say this laptop is a node. It runs the Bitcoin core software that's connected to the internet, listening for all new transactions, collecting them, grouping them together into a block. There's a minimum number of transactions that need to be there in a block. And then there's obviously a maximum size for a block. Once you've reached that threshold, and once you've also solved a puzzle, which requires a certain amount of time for you to solve that puzzle, you propose that block. Once that block gets accepted by everyone else, you've earned yourself a reward of 12.5 Bitcoins as of today.
Why would someone, you extrapolated that to, was it 2,140?
Yes.
It being free, why would someone spend all the money on that physical space, which is got to
Because they
be?
get paid it. Effectively, by doing that processing, he also actually creates Bitcoin and gets to use that Bitcoin in it.
Oh, right, and gets, what, some sort of a percentage on each Bitcoin that's used, or?
No, he, in the processing of the blockchain, he is creating new Bitcoins.
Oh, so it's like a reserve bank, sort of, is that the analogy?
Yeah.
Oh, good,
Yeah.
sorry.
So there's no central authority handing it to you. You say, I've earned it, right? And you put that transaction in there. I'll come to that. I'll go into a bit more detail about that. But this is an interesting thing about Bitcoins. It is the only currency, or the first currency, to say that there is a maximum limit of the number of my units in circulation, whereas no other physical currency ever had that. And no other digital currency before Bitcoin ever had this constraint, because they were trying to replicate what happens in the real world, whereas Bitcoin took a different approach, and it's successful. Yes.
Yeah. Now, in one node, you go and you actually create the hash function. So that's one part of it. Second one is storing this in different places. So where does it actually get stored? So what is the
block is stored on every node. Once the block gets appended to the blockchain, everyone needs to maintain it in their memory.
Individual users.
Yes. So the first time you install the Bitcoin core software on your system and you run it, I'll show you the website at the end of it. You can download the software and run it. It will take about a week to download everything, the full blockchain. It's about 200 gigabytes. Well, it depends on your network, how fast it can download. It's about 200 gigabytes of information that it downloads, and then you'll have the entire blockchain on your system, and you can play around with it. Or I'll show you a website that you can use that allows you to view the existing blockchain. You can start from block number 0, block number 1, see the first transaction, the incentive that Satoshi accumulated for himself, and then so on and so forth. Yeah.
Sorry. To become a node, do you buy it or you just download the software?
The software is free. You download it, you start running it, and you become a node.
Yeah. What sort of, you need a mainframe computer?
The requirements of the software aren't really much. Yeah, we could download it on this laptop and just start downloading the blockchain over the Google Wi-Fi over here. The computing power you need is to solve the puzzle, right? That's the difficult part. That's where a lot of large organizations or people with a lot of money are putting up huge amounts of money behind it to build large data centers or infrastructure to have these massive servers to compute the hash or the puzzle that needs to be solved to be able to propose the next block and get the block reward for themselves. So the website that I'll show to you at the end, you can see who's getting the reward. You'll see the public keys of all of them. Obviously, there are no identities over there that you can say that this is company A and that's company B and so on. But you can see that some public identities are regularly accumulating fresh Bitcoins that are being mined. And there are some that get it every so often. That's not the only incentive. There's one other incentive that's called transaction fees. So as a node, if I'm listening to different transactions as they happen, I group them together, I club them into a block, I solve the puzzle, I get the block reward. And I can also get something called a transaction fees, which is something that is voluntarily offered to me. I can't set a price on it. So it's not like Visa and MasterCard that I can say it's 2.5%. No, on every transaction. The transaction fees is offered to me. So two parties could say, hey, this person is buying this item from me for 1 Bitcoin, but the output of our transaction is 1.2 Bitcoins. So you transfer 1 Bitcoin to me and you keep 0.2 for yourself. but you make sure that this transaction gets into the block, the next block as soon as possible, and that's our transaction fee that we're offering to you. Someone else could offer me 1.5 Bitcoins, and someone could offer me 1.6 Bitcoins. It all depends, right? So why would someone offer a transaction fee, or why would someone offer a low transaction fee or a high transaction fee? Well, it's an incentive for them to make sure that their transaction gets into the block that's going to be added to the next block as the next block in the blockchain as soon as possible, right? If you want good service, you offer a high transaction fee. If you're okay with a lazy service, you offer 0 transaction fee. You'll end up on the blockchain somehow, sometime, but you won't be the next one on there, right? So nodes will obviously look for blocks, transactions which have a higher transaction fee and put them on the block first. So here's the puzzle that you need to solve. So it says, when concatenated to the previous hash and the list of transactions that comprise the proposed block, a hash is taken off the previous hash and the new transactions that have come in, and this output should fall in a small target space. So the input is the hash of the previous block on the blockchain, a hash of all the new transactions that have come in, appended with a special variable that we'll call nonce, and that's the nonce that you need to find. Together, the hash of this should be within a small target space. If you can find that nonce, you can you can propose the next valid block, right? Now that target space is what controls the difficulty level. It's a very tiny target space that needs to be met, right? So it's a very constrained objective that you're given. If you can't find it, you can't propose the next block, sorry. But if you can find it, that's good. And then subsequently, the target space is reduced further and further and further. That increases the difficulty. Now this is done because we know that over a period of time, computing power will continuously increase, or you can keep expanding the number of servers you have and sort of horizontally increase your computing power. So at some point, you might try to game the system, and the system says, well, you can't game me unless you can solve a more difficult puzzle the next time, right? So every subsequent puzzle is much more difficult, and that's why more computing power has to be continuously added by different nodes to be ahead of the game. Now, because the computing power is increasing, like you asked me earlier, yes, you need to have 50% of the computing power, not 50% of the nodes. So if I have one node which is the size of a data center, and that has more computing power than the rest of the nodes collectively worldwide, then I can beat them. It's not really 50% of the nodes. It's 50% of the computing power. But because the need of the computing power is continuously increasing to solve the next more difficult puzzle, I need to keep pumping in money to buy more hardware, keep expanding my system to make sure that it works fine. And that's not an easy task. We all know how difficult it is to keep building larger and larger data centers.
I mean, actually, the increase is exponential or geometric. I mean, how is the increase? Mathematically, how is the increase? I mean, when you need to sum up a new computer power?
It's directly correlated with the increase in decrease in the size of the target space, and that is neither geometric, neither exponential. Sorry, I don't have an answer for that, but that's a good question. I'll make sure I find out, and I'll leave my email ID at the end. If you can just email me, I'll get back to you on that. Yeah. I'm sure it's not exponential. So the target space is revised every time 2016 blocks are added to the blockchain. The system, the software, the Bitcoin core software revises the target space, and when the next block is proposed, 2017, the puzzle is more difficult to solve. Now, it's a rough estimate that 2016 blocks are created almost every 10 minutes. So it means that, the amount of time it takes today to solve the puzzle is about 10 minutes. So the next block that's proposed is every 10 minutes, because that's the amount of time it would take for one of the large systems somewhere in the world to solve that puzzle, right? This gives the system a sense of stability. There aren't blocks being proposed every now and then by different systems because it's spread all over the world. There's some latency. So 10 minutes is a very good amount of time to make sure that the right node proposes the correct block with the right number of transactions, and everyone can receive it, validate it, and agree to it, and then go on to proposing the next subsequent block. So here's some interesting statistics. So the minimum size of a transaction is 250 bytes. The maximum size of a block is 1 megabyte. So that means a block can have at maximum 4,000 transactions. Since a block is mined every 10 minutes, which means 10 minutes is the amount of time it takes for one of the nodes to solve the puzzle, there can be at max 7 transactions per second in Bitcoin. Right? Now that's not a very encouraging number. 7 transactions a second compared to the thousands of transactions that can be done on a Visa or a MasterCard network. That's not very encouraging, but the system's still working fine. It's thriving.
I have a question.
Yes.
Now, the transaction can be two, right? One is to mine and create a new hash.
Yes.
Second one is to validate the transfer of the bitcoins. Even that actually will create a transaction. So.
Okay, so a transaction is you saying, I'm the payer, here's the payee, here's my public key, here's payee's public key, here's the amount of bitcoins transferred from me to him, and here's the previous transaction from which sources this source of bitcoins that I'm transferring, right? That's all that a transaction is. So if you understand that, can you just rephrase your question again so that I better understand it?
So, okay, probably I didn't catch this bit. So for me, each block is, suppose if I'm going to create a new hash function, I'll just go and create that. That will create a new block. That is. You
want to create a new hash function. You'll have to use the hash function that's offered by the Bitcoin Core software.
That's perfect. So yeah. I will use that and I'll create a new block.
Right.
So, but I might be creating it. Now, two other gentlemen might be making the transaction using my block. Is that right? Because they will have the bitcoins already. They will have some hash which is already created.
Mm-hmm. So I'm not able to follow your question. If someone else can better explain the question to me, I'll try to answer it.
Okay.
Or I can talk to you afterwards. Is that?
Yeah, that's good.
Yeah. Okay. So one thing you should understand is that the system is peer-to-peer. There's latency. The nodes are not optimal. This isn't Google running the system, right? This is you and me, or maybe someone wealthy running the nodes. So the system really isn't reliable. So if I've done a transaction with you, and it could take some time for it to end up on the blockchain, and even when it gets added to the blockchain, it can get removed because a majority of the nodes might decide that this block that was added was invalid. Let's remove it. And if they all decide to remove it, they can check the block out, right? And the transaction's gone. So for us to make sure that the transaction's really gone through, we should wait for it to get added to the block to get added to the blockchain, and a few other blocks to get appended to the blockchain, right? What's our confidence level? Well, I'm new to Bitcoin, so I would probably wait for 10 blocks to get added to the blockchain before I say that the transactions really happened, right? You might be very familiar with the Bitcoin system and say, well, I'm comfortable with two blocks being appended. But definitely more than one block needs to be appended to the blockchain before we can say that the transaction is really valid, right? There's no central authority here. It's all decentralized. Interestingly, a transaction, the way I described it, is really what everyone uses to describe it to a beginner, but a transaction, it has inputs and outputs, and they're all scripts. The Bitcoin has a scripting language which has about 250 instructions. 90 of them aren't used, and these instructions sort of what lead to smart contracts between two parties. So a transaction is actually a smart contract. So we could have a transaction that says, pay him money 10 minutes from now. And the transaction could get added to the blockchain within a few milliseconds. and a few other blocks appended to it, but the money is actually transferred 10 minutes from now, right? Or I could have a smart contract that says, pay all of you money after I'm done with this presentation. Don't pay them before that, right? So those sort of smart contracts is what you can do with a Bitcoin transaction. And that's the technology, the blockchain and the smart contract technology is what's being now used by different companies outside Bitcoin for other purposes. I think we're at 45 minutes, so I will quickly go through a few slides and talk to you about a few negative scenarios in Bitcoin, which might be of more interest, and then we'll wrap it up. So a transaction, when it's received by the nodes, they quickly check, is it a valid transaction? Well, the way to check that is you run the script. So you run the output script, it should all run through and there shouldn't be any errors. And then you run the transaction that this transaction uses as an input. So if I'm spending 1 Bitcoin, where's that 1 Bitcoin coming from? From another previous transaction. So the nodes would look at that previous transaction, run the output scripts there, and that transaction would have a previous transaction, and they would go through that whole history, run all the output scripts, there should be no error, and that's fine. And that's when a transaction is a valid transaction. When is a block valid? So when I propose a block, all the nodes hear it, they look at the header, and they make sure that there are no transactions in the block that are invalid. So the output script should all run cleanly. There shouldn't be double spends. I have a slide on what double spend is. And they'll verify that I'm referring to the longest blockchain in the network, right? Double spend. So that's a very interesting thing. It's in the physical world, a double spend would be, let's say I have a Visa gift card for $10. I go to Kohl's, I swipe it, I buy something for $10. And then I go to Woolworths and I swipe it, and if I can somehow make that gift card work for one more time, spend another $10, and then I've actually used that card twice and made purchases worth $20, whereas it was only for $10. That's a double spend, right? It's very difficult to do a double spend with physical currency, but it's very easy to do that when you talk about digital currency. So let's say there's 2 transactions, or I'm a malicious person and I do a transaction with him and with him, and I say, give him 1 Bitcoin, and I say, give him 1 Bitcoin, and I use the same Bitcoin I got previously, right? Who's there how do these guys validate that I haven't done a double spend over there? So what they do is they'll publish this transaction and they'll say, well, we're not done till this transaction gets added to the block gets added to the blockchain, and then a few other blocks get appended to the blockchain. And while all that's happening, what will happen is some nodes will see transaction 1, other nodes will see transaction 2. So these 2 transactions, A and B, would go to different nodes. Because I'm running a malicious node, I'll make this happen somehow. So one set of nodes might pick up transaction A, another set of nodes will pick up transaction B. They'll all this block would have only transaction A, this block would have only transaction B, and that 2 different blocks being proposed on the network. And that's fine. So the system is meant to handle these scenarios. So there's two groups of nodes. One group of nodes has taken transaction A as valid and used that in the next block. Another group of nodes has taken transaction B as valid and put that on the blockchain. And now we have 2 different blockchains. And that's still fine. The system can still handle it. When the 3rd block is proposed, it will be on top of one of these 2 blockchains. And whichever one it selects is the blockchain that's the valid blockchain, because it's the longest blockchain. The other blockchain, which sort of diverged, is no longer the valid blockchain. So the block that was appended on that is considered invalid. All transactions are lost. They need to be republished and brought into the subsequent node. That is why you need to wait after a certain number of blocks have been appended.
But which one will be valid? I mean, the one which comes first, or I mean, actually
doesn't matter.
Doesn't
doesn't matter. It's a decentralized system.
Which one comes first because it's a peer-to-peer network. One node might consider this one first, and the other node might consider the other one first because they're different parts of the world, got the message at different times.
Yeah.
So the first and second
It's not
doesn't make any sense.
It's not something consecutive.
So it's just a matter of chance which one ends up being the one that happens to get the next block added correctly and ends up being the common one, commonly accepted as being valid.
Thank you.
So does this mean that if two nodes on other sides of the network come up with different nonces that validate a list of transactions,
Yes.
they then have a lottery as to which one gets consensus support across all the nodes?
You're right, yes. It's a distributed consensus. Only one of them will get selected. There could be more than two groups of nodes here proposing the next block. There could be more than two divergent blockchains out there. One of them will eventually win, and that will be considered the valid blockchain.
Right, and they're the one that get the reward for coining the block.
Yes, yes, exactly. So the block that gets accepted has a special transaction inserted in it, which has no inputs. That's the transaction that's called the Coinbase transaction. That's the transaction which has the reward for the node that proposes the next block. Right, so that's the 12.5 Bitcoins that gets the node. So now there could be three groups of nodes out there, three different divergent blockchains, three different nodes claiming 12.5 Bitcoins. But because only one of those chains will eventually become the longest chain, the other nodes will lose out on that 12.5 Bitcoins. So the Bitcoin software is called Bitcoin Core, which is published by bitcoincore.org. It's the Bitcoin developers community. You would have heard the terms hard fork and soft fork. I thought it'd be good to bring that up in this discussion. Any change to that software could lead to a hard fork or a soft fork. So just quickly go through what they are. A soft fork is what's acceptable. A hard fork is what is not acceptable. A soft fork is when features are introduced which make validation rules more strict. A hard fork is when features are introduced which would validate blocks which would have been previously considered invalid, right? I will skip to the next slide where you can see that diagram at the bottom. So what happens in a soft fork is there's a few nodes which haven't upgraded to the latest Bitcoin Core software. A few other nodes have. So the new software will have much more stricter rules, and it will consider certain blocks invalid. The old nodes, or the nodes running the old software, would continue running less strict rules, and they would validate certain blocks which the new nodes aren't validating. Eventually, the software is able to detect that there's been a version upgrade, that there's continuously this inconsistency between which are the new blocks being added to the blockchain, and it will alert its, let's say, administrator that you need to upgrade. A hard fork is where the software is not able to understand what's going on and thus not able to alert its administrator that, hey, I'm running off a blockchain that's no longer valid. Right? So the Bitcoin community is consistently trying to avoid making changes that will lead to a hard fork. There have been scenarios where a hard fork was inadvertently released and had to be rolled back, and that led to certain loss of confidence. I would suggest you look at bitcoin.org. There's a good tutorial. Lots of good things to read over there. Bitcoincore.org is the website from where you can download the software. It's available for all the operating systems. Blockchain.info is a very good website where you can look at the current most valid blockchain. You can also look at the blocks being proposed. What transactions are there? What identities are there? You can see the first few blocks. How did they get created? Right? Who were the people that benefited from the block rewards for the first 210,000 blocks because they all got the 50 Bitcoins, right? if you have any question that I haven't answered, you can just email me and I will try to get back to you. And I have this blog where I write about Bitcoin and certain other technologies. You can, if I find that I don't understand something that you pointed out, I will definitely write about that and reply to you and also update my blog. Yes?
It's my understanding that in order for your transaction to be validated, at least one additional block is going to go added to the chain after the one that your transaction is in. So you're looking at about at least 10, maybe 20, maybe even half an hour.
Yes.
Before your transaction.
Yeah, I'd say more than one block should be appended after your block. Yes.
So if a block's been added every 10 minutes, it could be half an hour before you can consider your transaction to be.
That's correct. Yes.
It's my understanding that for day-to-day stuff, there are organizations out there who will accept your transaction and process it on upcoming blockchains in such so as you can have a more immediate response to the transaction.
Yes, you would have heard of Mt. Gox. That was a famous Bitcoin repository, exchange, bank, whatever that went down, and they tried to offer these sort of services. They saw that there were these drawbacks where people had to wait a certain amount of time for their transaction to be actually considered a valid transaction, for them to have confidence that their transaction has really gone through. And they tried to offer these services on top of this. So they said, well, you could be offline and I'll still give you a way to transfer Bitcoins or receive Bitcoins. Unfortunately, they had their own issues. They were not, some of these organizations weren't trustworthy. Some of these organizations had technical loopholes where they somehow lost money. So losing money effectively means that they lost access to their private keys. Someone gained access to that and transferred the money to different other public keys and then transferred it from there to some other public keys, and that money's been siphoned away. So it's not a perfect system, just like cash isn't a perfect system, digital cash isn't a perfect system, digital currency is also not a perfect system. It's inflexible in certain ways, but it's definitely, it has certain features that cash does not give to you or digital cash does not give to you. For example, it's not backed by any government, right? It's not, you're not bound to lose the value of your Bitcoin if there's a war in a certain part of the world, whereas with currency you're likely to. Yes?
I believe China's objecting to having has a large amount of the service because it's very cheap in China
the hardware.
to provide, and China politically is objecting to it being located there. So
Yes.
there could actually be a giant.
Yes, so different countries have different currency controls. So Australia is very open when you need to convert your Australian dollars to any other currency. You're free to do that. Certain other countries don't allow that. There's no free currency fungibility in those countries. And blockchain is now, Bitcoin is now recognized as a currency by them, and they want to bring that into the purview of their currency laws. So that is one way for them to do that. So they understand that this runs on top of hardware, and if I can control that hardware, I can control the flow of that currency.
A bit more, but yeah, anyway, yeah, someone's probably got other questions.
Yes?
Just with the Bitcoin difficulty, I've heard that one of the issues you run through at the moment is...
Sorry, I couldn't hear you.
Yeah, sure. So I've heard that one of the issues with the Bitcoin difficulty is it's getting more and more difficult, and that's partially because you've got people buying hardware so that they're able to mine as fast as they otherwise would be able to.
Yes.
And what that may then cause in the future is that it'll become not economically profitable, it'll be able to mine Bitcoin, and so that will cause some kind of crash where people start going.
Yeah, I understand what your question is. Right. So effectively, the question is, the cost of mining Bitcoin is the cost of solving the puzzle, which is the electricity cost of running the hardware and keeping it cooled and continuously increasing your computing power. And is it worth the effort? Well, it just depends on the exchange rate for the Bitcoin, right? If you're paying for electricity in Australian dollars. And if a Bitcoin is worth, one Bitcoin is worth 1,000 Aussie dollars, then maybe it's worth it. If it's not, then it's not worth it. So there have been currencies that have become so worthless that it was, you could earn more by recycling the paper on which they're printed, right? So it's the same thing. The same concept applies to Bitcoin.
What are you saying? You don't want to be the last one holding right at the end. What did you say? 2014?
Yeah, so that's an interesting thing. What would happen in 2140, or what would happen as we approach 2140?
You want to be holding the hot potato.
Yes, exactly, right?
Quick.
That's a very good analogy. Hot potato is used a lot in macroeconomics. Like, no one really wants to hold it, right? If the interest rates go up, let's say the savings bank interest rate goes up to 10%, why would I want to hold cash in my pocket? Right? It becomes hot potato. I'd like to keep that in the bank, get some interest on it. But if the interest rates are low, and the government wants me to take the money out and spend it, there's no point holding on to it. Yes.
I think there's an infrastructure that's being added to Bitcoin. Bitcoin's sort of the beginnings. It's becoming quite an extended commercial system.
Yes.
Most of the banks are interested in one way or another.
Yeah. So banks or investment banks are always happy to find financial products, new financial products. That's how new business is found in the financial industry, and Bitcoin is a new financial product. It's a new currency. There are other currencies like Ethereum and this Faircoin, and they have different philosophies behind them. Some of them don't have a limit. Some of them have different way of incentivizing in the minting process, or the transaction fees, or there's something else built into them. Bitcoin is more famous as the first successful implementation, but yes, it probably isn't the last one. There's likely to be more implementations that might succeed.
Hi, as I understand it, I think because it's getting harder and harder to mine Bitcoins, people are pooling together to kind of form kind of groups of miners. As those kind of mining pools get larger and larger, kind of basically what happens when we only have a very small number of mining pools in the future?
Yeah, so that's more of a human behavior question. So what if smaller nodes join together to compete against larger nodes, and what happens? Do more larger nodes come in? Do the larger nodes become even more larger? That's all human behavior dependent. There's no really right or wrong answer here. We don't know what's going to happen in the future.
Will it destabilize any aspect of the design?
I think there will be other factors that you should consider. What if there's a war? What if there's World War III? Let's just take a worst case scenario. World War III starts. But all of us have an opportunity to connect to the Wi-Fi and convert our cash into Bitcoin. Would we take that opportunity? Because I don't know.
I suspect it's more likely that a government like China could try to fund massive amounts of computing power to try to take a controlling ownership of the computing power.
So like I said,
it's probably more likely than hopefully it's more likely than
yeah. So like I said, mathematically it's possible.
If China tried to do that, probably there's going to be other countries also going to try to do that. And as long as there's more than two trying to do that, then no one of them is ever going to win.
Yeah, that's a good way to say it.
And there's more than one. That's what I was trying to say before. Bitcoin is the same. It's just the beginning. There's a whole lot more that are either already hit and about to hit.
Yeah. I've also heard a lot of people are using the Bitcoin blockchain for other things too, such as to have a permanent public record of something.
Right. So why not have all the property registrations, blockchain, published online, available for anyone to look at, and not manipulable, so that you can't cheat someone, you can't sell the same property to two different people. So that's a very good use of blockchain. Yes, that's correct.
Apparently there's some political organization, I think in Tasmania or something, that if you voted them in, they would vote according to what their jurisdiction or whatever wanted them to, and they would have a blockchain record all that information.
There's so many different places where blockchain is being used. Companies like IBM and Microsoft have massive projects going on, so you should see a lot of interesting ideas come out of there.
Any more questions?
Actually, one quick question: the Bitcoin exchanges platform. I mean, actually, they are connected in any way to the network, or they are working like separate entities? Or
so when you open a Bitcoin exchange, you're effectively saying, I'm ready to offer you another currency for Bitcoin, right? So you're supporting that currency. Certain countries will allow you to do that. Certain countries will not allow you to do that because they have their own currency controls. There are laws in place, right? That's actually pretty much all there is to it, right? Whether you trust those exchanges, how trustworthy are they? Who are the people backing them? What's the technology behind them? Can they somehow steal your private keys? Do you store your Bitcoins with them? These are all different features and issues that have come up with any organization that's tried to set up an independent exchange for Bitcoins. I'm not sure if you guys know, but on Pitt Street, Westfield, there was a Bitcoin ATM in the food court downstairs. And there was a recent attempt by a company in the US to launch an ETF, an exchange-traded fund based on Bitcoins. I think it was the Winklevoss brothers that tried to sponsor that ETF, but it was rejected, yes. I might be wrong about the Winklevoss.
Any more questions? Thank you very much, Ritesh.
Thank you.
We usually go up to P1 Bridge Pub after this. You're all welcome. We can discuss more Bitcoin. Next month, I thought I'd do a talk on the way Linux has changed the way the whole boot process and all its infrastructure basically. So how we're using UFEI now and Grub2 and systemd instead of sysinit, and how sessions work up to logging D and that sort of thing. If anybody has a particular part they would like to hear about or has knowledge in this area, please come talk to me so I can hopefully do a better talk. And thank you very much.
You're welcome.